Science Class 9, Chapter 9, Force and Law of Motions, Part 2. Like, share and subscribe this channel for more notes and solutions. Question 11. Two objects each of mass 1.5 kg are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. What will be the velocity of the combined object after collision? Answer. Mass of the object m1 is equal to m2 equal to 1.5 kg because both masses are same. Velocity of first object v1 equal to 2.5 meter per second and velocity of second object v2 equal to minus 2.5 meter per second because opposite. Momentum before collision equal to m1 v1 plus m2 v2. This is the formula of momentum. Now putting the values of mass and velocity is equal to 1.5 into 2.5 plus 1.5 into minus 2.5 equal to 0 because due to negative sign. Momentum after collision is equal to m1 plus m2, that is 1.5 plus 1.5 is equal to 3 kg. After collision velocity, now find out it. According to the law of conservation of momentum, means momentum before collision is equal to momentum after collision, that is 0 equal to 3 into v. Therefore v equal to 0. Question number 12. According to the third law of motion, when we push on an object, the object pushes back on us with an equal and opposite force. If the object is a massive truck parked along the roadside, it will probably not move. A student justifies this by answering that the two opposite and equal forces cancel each other. Comments on this logic and explain with why the truck does not move. Answer. The mass of truck is too large and hence its inertia is too high. The small force exerted on the truck cannot move it and the truck remains at rest for the truck to attain motion. An external large amount of unbalanced force need to be exerted on it. Question number 13. A hockey ball of mass 200 gram traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity of 5 meter per second. Calculate the change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. Answer. Mass of ball m equal to 200 gram equal to 0.2 kilogram. Initial speed of ball u equal to 10 meter per second. Final speed of ball v equal to minus 5 meter per second. Initial momentum of the ball is equal to m into u, that is 0.2 kg into 10 meter per second, or it equal to 2 kg meter per second. Final momentum of the ball equal to m into v is equal to 0.2 kg into minus 5 meter per second, that is minus 1 kg meter per second. Hence change in momentum means final momentum minus initial momentum, or difference in the momentum, that is 2 minus minus 1, or equal to 2 plus 1 is equal to 3 kilogram meter per second. Question number 14. A bullet of mass 10 p traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 second. Calculate the distance of penetrations of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. Answer: m equal to 10 gram, it converted into kg, that is 10 upon 1000 is equal to 0.01 kg, and u equal to 150 meter per second, v equal to 0 meter per second, time t equal to 0.03 second. Now applying the first equation of motion, v equal to u plus at, that is 0 equal to 150 plus a into 0.03. Now a equal to minus 150 upon 0.03, that is minus 5000 meter per second square. This is acceleration. Now find out the s and f. Applying the formula, third equation of motion, that is v square minus u square equal to 2s. 0 square minus 150 square is equal to 2 into 5000 into s. Therefore s equal to 150 into 150 upon 2 into 5000, or s equal to 22,500 upon 10,000. Therefore s equal to 2.25 meter. Therefore the penetrations distance of the bullet in the wooden block equal to 2.25 meter, and magnitude of force F equal to ma. Apply this formula, value of m and a is 10 upon 1000 into 5000, that is F equal to 50 Newton. Question number 15. An object of mass 1 kg traveling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the before the impact and just after the impact. Also calculate the velocity of the combined object. Answer: m1 equal to 1 kg and v1 equal to 10 meter per second. Mass of wooden block equal to 5 kg. m2 equal to 5 kg plus 1 kg, that is combined object. It means 6 kg. Now velocity of combined object v2 equal to, now find out it. Therefore rho 1 and rho 2 equal to, that is momentum. Momentum before impact means P equal to m1 v1 equal to 1 into 10, that is 10 kg meter per second, and therefore momentum before impact equal to momentum after impact according to the law of conservation. m1 v1 equal to m2 v2, or 10 kg meter per second equal to 6 v2. Therefore v2 equal to 10 upon 6 or 1.67 meter per second. Question number 16. An object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. 6 seconds. Okay. Calculate the initial and final momentum of the object. Also find the magnitude of the force exerted on the object. Okay. Answer: m equal to 100 kg, u equal to 5 meter per second, v equal to 8 meter second, and time t equal to 6 second. And find out the rho 1, that is momentum 1 and momentum 2, and force. Therefore initial momentum rho 1 equal to m into u is equal to 100 into 5, that is 500 kg meter per second, and final momentum, that is rho 2 equal to m into v is equal to 100 into 8, that is 100 kg meter per second. Force exerted on the object, that is F equal to m into a, or equal to 100 into u minus v upon t, v minus u upon t, that is 800 into 8 minus 5 upon 6, or is equal to 100 into 3 upon 6, that is 50 Newton. Question number 17. Akhtar, Kiran and Rahul were riding in a motor car that was moving with a high velocity on an expressway when an insect hit the windshield and got stuck on the windscreen. Akhtar and Kiran started pondering over the situation. Kiran suggested that the insect suffered a greater change in momentum as compared to the change in momentum of the motor car. Because the change in the velocity of insect was much more than that of the motor car. Akhtar said that since the motor car was moving with a larger velocity, it exerted a larger force on the insect, and as a result the insect died. Rahul, while putting an entirely new explanations, said that both the motor car and the insect experienced the same force and a change in their momentum. Comments on these suggestions. Answer. Rahul gave the correct reasoning and explanation that both the motor car and the insect experienced the same force and a change in their momentum as per the law of conservation of momentum. When two bodies collides, initial momentum before collision is equal to final momentum after collision is equal to m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. The equal force is exerted on both the bodies, but because the mass of insect is very small, it will suffer greater change in velocity. Question number 18. How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 cm? Take its downwards acceleration to be 10 meter per second square. Answer. Mass of dumbbell equal to 10 kg and height h equal to 80 cm, that is 0.8 meter. Acceleration 10 meter per second square. U initial velocity 0. Applying the third equation of motion, v equal to minus u square equal to 2as. V square minus 0 square equal to 2 into 10 into 0.8, that is v square equal to 16 or v equal to 4 meter per second. Momentum rho equal to m into v, that is 10 into 4 or 40 kilogram meter per second. Question 1. The following is the distance timetable on an object in motion. Time in second and distance in meters. 0 second 0 meter, 1 second 1 meter, 2 second 8 meter, 3 second 27 meter, 4 second 64 meter, 5 second 125 meter, 6 second 216 meter, 7 second 343 meter. Okay. A. What conclusion can you draw about the acceleration? Is it constant, increasing, decreasing or zero? And B. What do you infer about the forces acting on the object? Answer. As per given table, initial speed of the object is 0. Applying the relation as equal to ut plus half at square or as equal to half at square because initial velocity is 0. We have acceleration is equal to 2s upon t square. Therefore, first second a1 equal to 2s1 upon t1 square equal to 2 into 1 upon 1 square, that is 2 meter per second square. For first 2 second a1 equal to a2 equal to 2s2 upon t2 square, that is 2 into 8 upon 2 square, that is 4 meter per second square. For first 3 second a3 equal to 2s3 upon t3 square equal to 2 into 27 upon 3 square equal to 6 meter per second square, and so on. Question number 2. Two persons managed to push a motor car of mass 1200 kg at a uniform velocity along a level road. The same motor car can be pushed by 3 persons to produce an acceleration of 0.2 meter per second square. With what forces does each person push the motor car? Assume that all persons push the motor car with the same muscular effort. Okay, answer. Let each person applies a force F on a motor car of mass m equal to 1200 kg. When two persons push the car, they just manage to move it at a uniform velocity. It means that their combined force 2F is just balanced by a force of friction due to road and car moves with a uniform velocity. When three persons push the car, they apply a total force 3F on the car. Now, net unbalanced force on the car is equal to force applied by 3 persons minus frictional force is equal to 3F minus 2F is equal to F. As now acceleration A equal to 0.2 meter per second square. Hence, F equal to mass into acceleration. Therefore, force is equal to 1200 into 0.2, that is 240 Newton. Hence, each person pushes the car with a force of 240 Newton. Question number 3. A hammer of mass 500 gram moving at 50 meter per second strikes a nail. The nail stops the hammer in a very short time of 0.01 second. What is the force of the nail on the hammer? Answer. Mass of hammer m equal to 500 gram, that is 0.5 kilogram. Initial velocity of hammer u equal to 50 meter per second. Final velocity of hammer v equal to 0 and time t equal to 0.01 second. Therefore, acceleration of the hammer is a equal to v minus u upon t. Now putting the value of velocity and time, 0 minus 50 upon 0.01 is equal to minus 5000 meter per second square. Therefore, force applied by the nail on hammer F equal to m into a, or 0.5 into minus 5000, that is equal to minus 2500 Newton, where the negative sign of the force suggests that the force is opposing the motion of hammer. Question number 4. A motor car of mass 1200 kg is moving along a straight line with a uniform velocity of 90 kg per hour. Its velocity is slowed down to 18 km per hour in 4 seconds by an unbalanced external force. Calculate the acceleration and change in momentum. Also calculate the magnitude of the force required. Answer. Initial velocity of car u equal to 90 km per hour, that is 90 into 5 upon 18 meter per second is equal to 25 meter per second. Final velocity of car 18 km per hour, that is 18 into 5 upon 18 is equal to 5 meter per second, and time t equal to 4 seconds. Therefore, acceleration a equal to v minus u upon t is equal to 5 minus 25 upon 4, or equal to minus 5 meter per second square. Change in momentum of car mv minus mu is equal to m into v minus u, or 1200 into m minus 25. 1200 into 5 minus 25 is equal to minus 24,000 kilogram per meter per second, kilogram meter per second. And magnitude of force F equal to m into a, that is 1200 into minus 5, that is minus 600 Newton. We have negative sign of acceleration, change in momentum, and force suggests that the force is opposing the motion of the motor car. Question number 5. A large truck and a car, both moving with a velocity of magnitude v, have a head-on collision and both of them come to a halt after that, if the collision lasts for 1 second. A. Which vehicle experiences the greater force of impact? Answer. A. During head-on collision, forces applied by truck and car are action-reaction forces. Hence, both vehicles experience same equal force if of impact. B. Which vehicle experiences the greater change in momentum? Answer of B. Here, initial velocity of both car and truck is same equal to v, and final velocity of both is 0. But mass of truck is much more than that of car, hence the change in momentum of truck is more than change in momentum of car. Question C. Which vehicle experiences the greater acceleration? Answer C. For same force of impact, the acceleration of car will have greater magnitude because its mass is less. Question D. Why is the car likely to suffer more damage than the truck? Answer of D. Car suffers more damage than the truck as acceleration of car is more. Its velocity falls to 0 in a shorter time and consequently its momentum changes in a shorter time. Thank you students. Keep watching next videos. Subscribe and share. Smart Physixia Academy. This is the end of chapter 9 of class 9th part 2.